Okay, so in the previous video, we estimated the sample correlation coefficient R to be 0.88. So in this video, we're going to test the hypothesis that the population correlation coefficient is 0. Okay, so the alternative hypothesis will be that the population correlation coefficient is not 0. And so population correlation coefficient is often noted by the Greek letter rho, okay, which on a computer, you might just write p because rho looks kind of similar to p. So we're going to be testing, so let's do the test if rho equals 0. Okay, so the null hypothesis is that rho equals 0. So this is a two-sided test. In order to do this test, first thing we need to do is calculate our test statistic. So we're going to need to know this equation. So what is the test statistic? So the test statistic is R. So I'm just going to actually write equals, and then I'm going to click on the R cell, and I'll say divided by, and I need parentheses, and then I'm going to write square root SQRT, and I'll say 1 minus, and I'll click on the R again, I'll square that, and I want this all to be on top, so I'm going to need to put it in parentheses. This divided by n minus 2. So let's see, I'm going to need that to be in parentheses as well. So n is the sample size, so I need to count how many data points I have. I have 10 data points there, so 10 minus 2. End those parentheses, and then end the last set. Okay, and then press enter, and so you get your test statistic of 5.3. Of course, you can also use a calculator to calculate this. You don't need to use Excel to calculate that test statistic. Just since we're already in Excel, might as well use it. Okay, so next thing is to calculate the p-value. So we have a two-sided test. So we know we're going to be doing 2 times the p-value of, say, if we're one-sided, and this is a t-distribution, so I'm going to be using t.dist. So I'll go ahead and hit my t-statistic. And what's my degrees of freedom? Alright, so degrees of freedom is usually n minus 1, but in this case it's n minus 2, so don't forget that. So that'll be 10 minus 2. And you write true for cumulative. Yes, you want it to be cumulative. And of course, I need it to be 2 times. And then this, since this is a positive number, will calculate the area that's behind the positive number, right? Which is not. I want the area that's in front of the positive number, and then I want the area that's behind the negative version of this number. Both those are the same, so that's why we just do 2 times. So I'm going to do the negative version by putting a negative sign in front of this, 5. Okay, I get 0.0007. So that's less than alpha, if alpha were 0.05. So you would reject the null hypothesis and say that there's evidence that suggests the population correlation coefficient is not equal to 0. If you were to use critical values instead of using a p-value, so of course you have to decide if you want to use p-values or critical values. You don't do both. But if you were to do critical values instead, you would be using t.inverse, and depending on what your level of alpha is, so let's say alpha is 0.05, you'd write 0.05, and it's two-sided, so you'd have to divide that in 2, and then your degrees of freedom is 10 minus 2, 8. So, or use critical values with alpha equals 0.5. Okay, so since this is this one would be the lower bound, and you could just do negative and then press this one. So the upper bound would just be the opposite sign. So you would say, okay, well, I'm going to reject HO if the test statistic is more than less than negative 2.31 or more than 2.31. Okay, and since our I'm going to move this down one. So since our observed value is more than 2.31, you would then make the decision that yes, okay, I'm going to reject the null hypothesis and conclude that there's evidence that the population correlation coefficient is not equal to 0.